he follows the line, and when it gets to the green flag, he will send a message to the slave saying, okay.
We based this project in Alzheimer's people. 35% of 60-year-old people have Alzheimer, but as you may know, it affects people's memories. And also we need to target the people that are disabled. So we made this project that is a medical assistant that will remind them to take the pills when they are sick, or maybe when they have like a disability and they need to take a pill or something.
Okay, in this project we use two kits of Lego EV3. We use motors, distance sensors, color sensors, and we use acrylic and color paper for distinguish the flags. So the algorithms is very simple. We use two modules. In this case, they are connected by Bluetooth. We use the simple model master-slave. The master controls the slave by sending messages, and the slave receives it, and then comes back with an answer. So if we can restart it, we have a timer because, as you know, each pill needs to be drink or consumed a certain hour or certain each time. So for example, in this case we put it 50 seconds past, so we are going to start the programmation. The master will go around the lab, and with the lateral color sensor he will detect the green flag. When he detects that, he will stop, and automatically he will send a message to the slave saying what pill he wants depending on the hour. The slave will respond to that message with another message saying the quantity of pills he has of that type. Then, as you can see, after that the master will say, okay, give me one of that pill, and automatically the slave will dispense it and grab it on the box. And this time we have the screen representing the quantity of pills and the timer in the master. Then the master will come all the way down here, back to the red flag. At the red flag, we have the stop place for saying like that. When we stop it, we will. It sounds like an alarm saying that it's ready. And also for deaf people, we have the screen saying "Feel ready," so you will receive it. Also with the sensor, we will put the pad, and automatically the robot will throw you the pill. This will repeat a cycle with the 3 pills until we get out of pills. When we get out of pills, slave will send them a message to master saying we don't have any more pills, buy more.
In the future, we expect this robot used in nursing homes where sick people may be and disabled or Alzheimer's people are. So this robot could help them by remembering those pills, like for example for heart attacks or for even Alzheimer's also. Also, we expect to do an app where the doctor can say the pill if he needs to take, where can he buy it, and the interval of hours or days it needs to take, and then and that will make it easier for the patient, and you won't need any more programmation.
We think this project is not only for the people with Alzheimer. We think that many people with problems like for walking, they cannot go for the pill. So this robot will help him taking the pill until where they are and remember him when to drink it and which time it is. Also, we have a refill system. When the robot automatically gets out of pills, you only need to press this button, and automatically the value of the variables will restart again. Thank you very much.
So this is our robotic project, the Vulcan Fire Protection System. Did you know every year in the US, 1 million fires occur? And these fires take about 3,000 lives yearly. We wanted to help these people. So we found 3 main types of fires: wildfires, industrial fires, and residential fires. We found a solution for each type of fire and tried to robot it. It's inspired by sprinkler systems you can find in schools and businesses. When a wildfire is approaching a residential block that's close to the woods, there's almost nothing that can stop it. But like a sprinkler system, if we get everything wet, fire cannot spread very easily. That's pretty much what Arbor does. It is a sprinkler system installed on trees. Lighter. When it senses fire, sprays mist, wetting the vicinity, ensuring the fire does not spread. However, when a fire occurs in a factory, many things, there could be explosive gases, combustible dust, a tank of hydrogen, benzene can be produced. All of these are very toxic and bad. This is why we've built Canary. Canary would go into these factory fires, and if it senses something dangerous, it would make a signal, but it would also upload all the data onto the cloud. If the data that the firefighters can see, and this data is public, just look for Firefighter1 on ThinkSpeak.com. You'll find this data, and if this is too dangerous and the firefighter will be able to look at this, they will not go in, and we'll send in our other robot, Ranger. Ranger is a semi-autonomous firefighting robot. It will be able to shoot water at the fires, and it will especially go into places where Canary thought it was too dangerous, or a nuclear power plant fire, or places where people just cannot go. Finally, in residential fires, one of the biggest dangers is suffocation. In fact, according to Michigan State University, 50% of house fire fatalities are due to suffocation. Also, people may become trapped in debris. This is why we have Scout. Help me, I'm trapped.
Hang on. Help is on the way.
Scout will use object recognition and natural language processing algorithms to detect humans and or pets. It'll be able to understand what people are saying, and if there is somebody in there, it will raise this alarm, send a signal to alert the authorities that there's a victim here that needs rescuing. It can especially be used in places where people, not just in house fires, but say in a search and rescue mission, where we don't want to risk another life, just to make sure, if we don't know that there are survivors there or not, we can send it in to make sure, are there any survivors, instead of just having like another life lost in search of no survivors at all.
Okay, after you watch this show, I think you're curious on how do we make this robot up. Okay. You see that you can't see the robot in this side because we use a unidirectional shading paper. The principle of it is like a magic mirror. You see that when you stand at the bright side, you can't see anything in dark side. Or we can say that the robot is able to be hidden in dark. Also, and there's another question. How do we build a robot? The answer is quickly. We just need to like a robot. Therefore, we add another substance to it. It's like the optical fiber. We put it on the robot and attach it to the light source. Therefore, we can perform this show. And then involve another principle. It is total refraction. The effect of it guide the light. In this process, a part of light will be refracted. Then the coat which cocoon the fiber can absorb the light. Therefore, we can see the color of the light in the light path. In our program, we divide in two parts. The first part is about wireless control and initiation, and the second part is about choreography and light control. In our teamwork, in our discussion, we decide what should we do in the near future, and my teammate Aaron start to design and give me the diagram and teach me how to use the CNC and laser to cut the board out. And my another teammate Johnny, he built our robot out. Then we start to make the control, have the optical fiber, build the stage, running the program, and fix the robot on the stage individually. Also, after we built the robot, we also think that it's a nice project to explain the idea of STEAM. In science, we use the principle which we learned on the physics lesson, like total refraction and work and energies. And also, in technology, we blend the wireless control and unidirectional shading into our robot. In engineering, we design the structure of the robot joint by using compound level. In mathematics, we establish the equation by using circular function. The most important part is we use the light to depict the curve of the body. Therefore, we make the show be more amazing, be more wonderful. Finally, we wish you can enjoy the show. Thank you.